Welcome to episode 110 of your CySA Plus Prepcast. In this episode, we will examine two of the most crucial elements in digital forensics and incident response: evidence acquisition and chain of custody. These topics are not only relevant to handling cybersecurity incidents, but they are also vital for ensuring that any digital evidence collected stands up to legal or regulatory scrutiny. Understanding how to identify, collect, preserve, and document digital evidence is a core responsibility of every analyst and a significant part of your preparation for the CySA Plus certification. Mastery of these concepts allows professionals to contribute meaningfully to investigations while maintaining credibility and legal compliance throughout the process. To begin, let us define what we mean by evidence acquisition. In the context of cybersecurity, this refers to the structured process of identifying, collecting, and preserving digital data that may be relevant to a suspected security event. Evidence may include log files, system images, network captures, memory dumps, or specific files from workstations, servers, or mobile devices. The process must be methodical, and the tools used must not alter the original data. Every step taken must be documented, and the integrity of the collected information must be preserved for analysis and potential legal proceedings. Acquiring digital evidence properly is essential to ensure its admissibility and usefulness. Any compromise to the integrity of the data can render it invalid in a legal context or mislead an investigation. That is why forensic soundness is a core principle. Security professionals must ensure that their methods do not alter timestamps, metadata, or file contents. They must also ensure that any copies made are exact replicas of the original data source, and that the original data remains untouched and securely stored. The evidence acquisition process typically begins with identification. Incident responders assess the environment and determine which systems, applications, data sources, or network segments may contain relevant evidence. They then document these assets in detail. This includes not just system names or IP addresses, but also timeframes of interest, user account associations, and specific types of data suspected to be valuable for the investigation. Thorough documentation at this stage ensures that nothing is overlooked and that a structured acquisition plan can be developed. Once relevant systems and data sources have been identified, incident responders use secure methods to collect the information. These methods vary depending on the type of evidence and the condition of the system. Common techniques include disk imaging, memory acquisition, and network traffic capture. In each case, the emphasis is on minimizing disruption to the affected system while ensuring that the data collected is accurate and complete. The use of verified forensic tools is essential to maintain trust in the integrity of the data. Disk imaging is one of the most widely used techniques for preserving data from storage media. This method involves creating a bit-for-bit copy of the hard drive or storage device. The resulting image is an exact replica, including unallocated space, deleted files, and system metadata. Because the imaging process preserves the state of the drive at a specific point in time, it is ideal for later analysis without exposing the original drive to potential changes. Disk imaging also facilitates analysis using forensic platforms without risking contamination of the evidence. Memory acquisition is another critical practice. It involves capturing volatile data from a system's random access memory. Memory contents can include running processes, network connections, encryption keys, and evidence of malware residing in memory. Since memory is erased when a system is powered down, responders must act quickly and use tools designed to preserve the data without modifying it. Memory captures often provide insights that cannot be obtained from static disk images, especially in incidents involving advanced persistent threats or fileless malware. Network captures, often referred to as packet captures or PCAs, are essential for understanding the behavior of a threat actor across a network. These captures include raw data from network traffic and can reveal malicious communication with external domains, command and control activity, or data exfiltration attempts. During an incident, responders may configure systems to capture traffic in real time or collect historical data from network monitoring tools. Analyzing this data allows investigators to reconstruct attack timelines and identify the methods used by intruders. Proper evidence handling is not only about collection but also about preserving the integrity and authenticity of the evidence. Every piece of digital evidence must be labeled clearly, stored securely, and accessed only by authorized individuals. Improper storage or casual handling can damage evidence or call its legitimacy into question. Evidence should be encrypted, stored in a controlled environment, and monitored to prevent unauthorized access. Maintaining clear custody and handling procedures reduces the risk of evidence tampering or contamination. One important best practice in evidence acquisition is verifying the integrity of collected data using cryptographic hashes. Before and after data acquisition, responders generate hashes such as MD5 or SHA-256 to create digital fingerprints of the data. These fingerprints allow analysts and legal entities to confirm that the evidence has not been altered. If the hashes match during future validation, confidence in the authenticity of the data remains. Hash validation is a standard requirement in most forensic and legal procedures. Equally important is documenting the entire acquisition process. This includes the tools used, the personnel involved, the time and date of acquisition, the systems accessed, and the procedures followed. This documentation becomes part of the forensic record and is often reviewed in audits, legal proceedings, or internal investigations. It must be comprehensive and clear, allowing third parties to verify that proper protocols were followed. Poor documentation can cast doubt on the entire investigation and reduce the credibility of the findings. For more cyber-related content and books, please check out cyberauthor.me. Also, there are more security courses on cybersecurity and more at baremetalcyber.com. Chain of custody is the formal process by which the handling of evidence is tracked and documented from the moment it is collected to its final presentation or disposal. In cybersecurity, this is a legal and operational necessity. The purpose of a chain of custody is to ensure that the evidence remains intact, untampered, and authentic throughout its life cycle. Every person who accesses or interacts with the evidence must be accounted for. This process provides legal defensibility by confirming that the evidence presented during an investigation or legal proceeding is the same evidence that was originally acquired during the incident response. The chain of custody begins at the point of evidence collection. From that moment, every movement, transfer, or access must be documented with a clear record of who handled the evidence, when it was accessed, where it was stored, and why it was accessed. This record is not optional, it is a mandatory part of maintaining evidentiary credibility. Even a single undocumented access could result in the evidence being excluded from court or rejected by regulators. Therefore, meticulous record keeping is a non-negotiable standard in the forensic handling of digital materials. Each transfer of custody must include specific details. These details typically include the name of the individual transferring and receiving the evidence, the exact date and time, the location of the transfer, and the purpose of the transfer. For example, moving a forensic disk image from one analyst to another must be recorded in a custody log. Even if the transfer occurs internally within the same team, it must still be documented. This transparency ensures that there is no gap in the history of how the evidence was handled. Secure storage is another essential component of maintaining the chain of custody. Digital evidence should be stored in controlled environments that limit physical and digital access. This might include secure servers, locked evidence cabinets, or digitally isolated forensic labs. Access controls, surveillance logs, and encryption mechanisms are all common features of secure evidence storage environments. These measures reduce the risk of accidental or malicious tampering and support the integrity of the entire investigative process. When evidence needs to be transported between locations or handed off to another party, organizations must use secure transfer methods. This includes using encrypted storage devices, sealed evidence containers, and secure courier services. In addition, a transfer log must be completed, recording the individuals involved, the date, time, and reason for transfer. Chain of custody is not only about storage. It also extends to transportation, making it critical to ensure that the movement of evidence is as controlled as its collection and storage. Technology plays an increasingly important role in chain of custody management. Many organizations utilize forensic case management platforms that automate custody tracking. These systems provide digital logs, automated timestamps, and permission-based access tracking. They also allow evidence to be associated with specific cases, analysts, and procedures. This automation reduces human error and improves the consistency of custody records across large-scale investigations involving multiple teams and evidence types. Regular audits of chain of custody processes are a best practice. These audits validate that the documented handling of evidence matches operational records and that storage conditions meet policy requirements. Audits may be internal or external and often include reviews of physical storage conditions, digital access logs, and case files. They are also essential for ensuring compliance with legal, industry, and organizational standards. When discrepancies are found, corrective actions must be documented and implemented to reinforce the integrity of the process. Compliance is a critical reason why chain of custody procedures must be followed rigorously. Regulatory frameworks such as the Payment Card Industry Data Security Standard, the Health Insurance Portability and Accountability Act, and the General Data Protection Regulation may require evidence retention and documentation as part of incident response or breach notification processes. Failing to maintain a valid chain of custody could result in legal penalties, audit findings, or the dismissal of evidence during litigation. Training plays a key role in supporting proper chain of custody. Incident response teams must be trained not only in detection and remediation, but also in evidence handling and documentation. This training should include mock exercises, incident walkthroughs, and reviews of real-world case studies. The goal is to ensure that every member of the response team understands their role in preserving the integrity of digital evidence and contributing to legally defensible investigations. Ultimately, the documentation of both the evidence acquisition process and the chain of custody serves as the foundation for credibility in cybersecurity investigations. Without it, even the most technically sound analysis may be dismissed as unreliable or inadmissible. Organizations that implement structured, well-documented processes reduce their risk, improve their legal standing, and demonstrate operational maturity in the face of cybersecurity incidents. These practices are not just recommended, they are essential for maintaining trust and compliance in a digital threat landscape. To summarize episode 110, we have covered the essentials of evidence acquisition and chain of custody, two pillars of effective incident response and digital forensics. Evidence acquisition involves structured, secure techniques like disk imaging, memory capture, and network analysis, along with integrity verification and documentation. Chain of custody ensures that the handling of that evidence is properly tracked, recorded, and protected from the moment it is collected to its final use in investigations or legal proceedings. Both practices are deeply integrated into cybersecurity operations and are vital for CySA Plus certification success. With a strong understanding of these concepts, you will be prepared to contribute confidently and competently to any forensic investigation or incident response effort. Thanks for listening. To learn more about cybersecurity, please visit baremetalcyber.com. There you will find best-selling books, videos, and even more free cybersecurity training courses. Please subscribe to the Prepcast and our various podcasts. And thanks for listening.